Welcome to aminacademy.com. In quantum mechanics, let us discuss wave packets and uncertainty relation. The wave and particle aspects of electromagnetic radiation and matter can be united through the concept of wave packets. A wave packet is a superposition of waves. We can construct a wave packet in which the waves interfere with each other almost completely outside a given spatial region. We thus obtain a localized wave packets that can be considered an approximate description of a classical particle. A wave packet consisting of a superposition of plane wave may be formed. Now, further discussion about uncertainty principle of a wave. That is, in classical physics, studying the behavior of a physical system is often a simple task due to the fact of several physical quantities can be measured simultaneously. However, this possibility is absent in the quantum world. In 1927, the German physicist Werner Heisenberg described such limitation as the Heisenberg's uncertainty principle or simply the uncertainty principle, stating that it is not possible to measure both momentum and position of a particle simultaneously. The Heisenberg's uncertainty principle is a fundamental theory in quantum mechanics that defines why a scientist cannot measure multiple quantum variables simultaneously until the dawn of quantum mechanics. Dawn of quantum mechanics. It was held as the fact that all variables of an object could be known to exact precision simultaneously. For a given moment, Newtonian physics placed no limits on how better procedures and techniques could reduce measurements. Uncertainty, so that it was conceivable that with proper care and accuracy of all information could be defined. Heisenberg made the bold proposition that there is a lower limit to this precision, making our knowledge of particle inherently uncertain. Probability. Matter and photons are waves, implying they are spread out over some distances. What is the position of a particle, such as an electron? Is it at the center of the wave? The answer lies in how you measure the position of an electron. Experiments show that you will find the electron at some definite location, unlike a wave. But if you set up exactly the same situation and measure it again, you will find the electrons in a different location. That means every time its location is changing in it, the atom. Often for outside any experimental uncertainty in your measurement. Repeated measurement will display a statistical distribution, the location that appears of the electron. Now we'll discuss further detail about wave packets and uncertainty relation. Some detail. In quantum physics, a wave packet is localized transient burst of waves formed by the superpositions of many individual plane waves with slightly different wavelengths and momenta. It represents a quantum particles combining its wave and particle aspects by being concentrated in a small region of space where the particle is most likely to be found while also having a spread in momentum. Some key characteristics. Superposition of wave. What is that? A wave packet is not a single wave but rather a combination of numerous waves with different wavelengths and amplitudes. These waves interfere constructively in a small region of space, creating a localized wave, and destructively in other regions, causing the wave to diminish. That means destructive and constructive. Look at here, two waves in phase, and resultant waves is like superposition of a waves is the principle starting that when two or more waves overlap, the resulting waves amplitude at any point is the algebraic sum of the individual wave amplitudes at that point. This phenomenon leads to interference, where waves can combine to create larger amplitudes, that is constructive interference, or cancel each other out, that is called destructive interference. A concept applicable to all wave types, including light, sound, and water waves. What is localization? The constructive interference is in a localized region means the wave packet is concentrated in space approximating the position of the particle. In the context of a wave mechanics, superposition leads to a localized when multiple waves interfere constructively in a specific contained region of space and destructively everywhere else. This concentrated traveling disturbance is known as wave packets, which can represent a particle in quantum mechanics or a signal in classical physics. Heisenberg uncertainty principle. A wave packet embodies the uncertainty principle. A wave packet that is narrow in position space, well-defined position, must be wide in momentum space, uncertain momentum, and vice versa. The Heisenberg's uncertainty principle states that it's fundamentally impossible to know both the exact position and exact momentum or velocity of a particle simultaneously. As you measure one property more precisely, the uncertainty in other properly increases, creating a trade-off. This principle is a core concept of quantum mechanics and is significant for subatomic particles due to their tiny masses, but has negligible effects of microscopic objects. Here, the group velocity. The individual waves within the packets travel at their own phase velocity, but the entire packets or group moves with the distinct group velocity. Group velocity is the speed at which the overall shape of an object group of waves or wave packets travels. It is distinct from the phase velocity, which is the speed of individual peaks or crests within that wave. This difference becomes especially important in dispersive media where waves of different frequencies travel at different speeds. Particle representation. In quantum mechanics, a particle is not represented by a single non-physical plane wave with a definite momentum, but by a wave packets that gives a probable location and a range of momenta. How it works? Constructing the packet. Imagine combining many waves that sync slightly different wavelengths. Interference. These waves interfere with each other. Localized wave. Due to their different properties, they will constructively interfere at a single point or a small region, while elsewhere they will destructively interfere, cancelling each other out. Particle appearance. This localized wave or wave packets is the quantum representation of a particle with the particle's presence indicated by the non-zero amplitude of the wave packet. In summary form, we can say a wave packet is a fundamental concept in quantum mechanics that allows for the description of particles as localized disturbances that simultaneously possess both wave-like properties and particles-like characteristics, governed by a probabilistic nature of and uncertainty of the quantum world. So far, we discussed about in quantum mechanics wave packets and uncertainty relations. We have done. Please subscribe our YouTube channel.